Okay, I'm going to talk about the trapezoid rule, and that's the second one that's on the sheet that I handed out today. And to sort of set things up here, now a trapezoid looks like this. So it's a rectangle with a slant top, and this is going to be the midpoint right here. This is height 1, this is height 2, and this is going to be the width. And the area of the trapezoid is going to be it's going to be equal to h1 plus h2, the two heights, divided by 2, so their average, times the width. Well, why is that? Well, here's why. I'm going to transform this into a rectangle. Now notice that this point right here is midway between the first height and the second way. So this is h1 plus h2 over 2. That's what this height is right here. So what I'm going to do is I'm going to move this rectangle over here. So I'm going to transform this without changing the area. So what I'm going to do is move this piece over here, just like I'm doing there, and that's going to give me this as my area. So that's, again, to here is h1, but this height right here is h1 plus h2 over 2, and this was the original h2, and here's the width. So when I move this over to here, I get a rectangle. The height of this rectangle is that. So these areas are the same, and here we get h1 plus h2 over 2 times w, area of the trapezoid. And so if you look at this piece right here, that's going to be height 1, left-hand height, height 2, right-hand height, divided by 2, times the width. Okay, we'll go over that more. So here I'm going to just draw some trapezoids. This one's really close. So this one looks like a pretty good fit. So we get 3 trapezoids. And what I want to do is I'm going to say that this integral is going to be close to the sum of the area of the trapezoids, T1 plus T2 plus T3. So I'm going to show you what that equals. So let me get a piece of paper. Okay. So here's T1. Here's T2. Here's T3. So here's going to be the first height right here. That's going to be f of x naught. Over here, f of x1. Over here, same height, f of x1, f of x2 over here, this height. And then here, these heights are the same in this height. Now, this is x0, x1, that's delta x. Again, we're going to use, as I mentioned in class, we're using uniform delta x. And so I'm going to get the sum of the areas, height 1, height 2, divided by 2, times delta x, the width, over here. F of x1 plus f of x2 over 2 times delta x, and this one over here, f of x2 plus f of x3 over 2 times delta x. So what I'm saying is that this is going to be approximately this integral. Okay. Now if you look at this, and if I write this as a sum, I'm going to get exactly this. K is equal to 1, K is equal to 2, K is equal to 3. I'm going to get this, and I'll write this as a sum so you can see what I'm doing. This is going to be the sum. K is equal to 1 to 3, which is our n. Now for K is equal to 1, notice we get 1 less. K is equal to 2, 1 less. K is equal to 3, we get x2, 1 less. So f of K minus 1, whatever this is, equal to K, equal to K. Divide by 2, average height times the width. Well, that's exactly that formula. So I'm going to work with this for a little bit, show you a couple different ways to write it, and then we'll do an example. Okay, so I'm going to take this sum and I'm going to unravel it here. I get f of x0 plus f of x1 over 2, each of these over 2, times delta x. Same thing here. Over 2 times delta x, and so forth. Okay, I can factor this out. Now, so I've taken these out. F of x is 0 over 2. Okay, how many of these do I have? I have 2 of those. Combine both of those. F of x1. Combine both of these. F of x2. And then finally I get the f of x3 over 2. Okay, a lot of people prefer to do it this way. So in other words, I'm going to rewrite the trapezoid on the next page. So here's what we're saying. This is the first summation. Now this is I can factor out that delta x and look at the pattern back over here. First one divided by 2, last one divided by 2, everything else is single. So you can go through and do this, which I encourage you to do. F of x0, the first one, over 2. Second one, I keep doing that until I get to the penultimate one. And then I get to the ultimate one. And I get that. Okay, so this is my trapezoid rule. And either one is fine. I kind of like this one. So what I'm going to do is the same problem we did in class. Using the trapezoid rule, n equal to 4. Okay, sorry I twisted that. So I'm going to do what I did before. Integral, I'm sorry, that's 1 to 2. That's x0, that's x4. 1 is x0. X4 is 2. Okay, so this will be x1, x2, x3. Delta x, uniform, a minus b over 4. So this will be 1 plus 1 half. Sorry, that's 1/4. This will be 5/4, 6/4, 3/2, 7/4. Okay. And so what I'm going to do is I'm going to use this version of it. So I'm going to say that my t-rule approximation is going to be this integral, 1, 2, cos x over x dx is approximated by delta x, f of x 0 over 2, so that's going to be cosine x0 over 1 over 2. F of x1 over here, so cosine x1 over 5/4. Cosine x2 cosine x3. x3 is 7/4 plus half of x4. Cosine 2 over 2 all over, all over this 1/2 right here. Sorry about that. So there's my f of x, there's my f of x, f of x2, f of x3, f of x4. So I do this out, and hold on for a second while I dig it up on Wolfram Alpha. And what I get from this was 0.09